So in this, our plan is to ping between the sites, customer site 1 and site 2. What we have covered in this is finished this, and this. We finished configuring all the underlay protocols, like ISIS is running here, and then MPLS is running, and then BGP between these two is running. BGP between these two, VRF aware BGP is running already. Sorry, not these two. On this we have finished configuring, but not on the PE2. PE2 is not configured yet. PE2 is blank. So we are going to finish PE2 with proper understanding of configuring from very basic host name to MPBGP. So with that, we will be able to complete this task, and then we will move on to having another customer here. Another customer here running OSPF maybe. Another customer, sorry, the same customer, remote site, running maybe a static route or a RIP protocol, or another OSPF, and then or ISIS, and then we'll see how the distribution of the route from OSPF to RIP happens via the core ISP, and then we'll move on to the other scenarios, like leaking routes from one PRF to another and so on. Purely service provider. So can't be finished in one day all this, but these are all the plans in the pipeline. L3VPN, after which we'll get into L2VPN VPLS with the same topology. This Juniper supports a lot of features, wonderful features. It's not easy to do VPLS in Cisco in all versions, but this supports all those things very easily. Now let's move on to router 2, PE2. The 10 steps. First, the router ID for ISIS is called as net ID or NSAP. The address that will have the 3 portion, area, system ID, and N selector, and then the IP address of the interfaces, and then we configure ISIS with level 2 wide metric enabled, and then MPLS LDP, then IP address on the loopback interface so that can be used as the router ID. VRF, when we say VRF, it includes the customer facing interface, route target, route distinguisher, and then we assign IP address to the customer facing interface, and then MPBGP configuration between the P's. This is not still done between the on PE1, so we have to do it on PE1 as well as on PE2. And this one, PC configuration, this is already done, the customer side is already done. That's it. So when we do this 10 step, we'll be able to finish this task. Now for PE2, this is going to be the NSAP configuration. Set up loopback interface as the ISO NSAP ID. For that we type set interface loopback 0 unit 0 family ISO. The reason why it is not INET is CLNS protocol uses ISO standard, not the OSI standard. So it's ISO address and then this. I'm going to copy this and put it on router 2. The first step gets over when I put this on router 2. P2, already host name is configured. I can see PE2 there, and login is root. Password is JUNIPER123. I'm in. CLI config, and I paste this commit. Step 1 is over. Step 2, assigning IP address. If we notice here, we need to assign 10.25.05 as a 002 on E1, 26.02 on E2, 26.02 on E2, E1 25.02. Set interface E1 unit 0 family INET. It is IPv4, so ready to go. P2. Let's commit again. What is next? Step 3 is we set the router ID. This one I'm going to configure this one, so that's what I have in the order here. We're naming route option router ID the loopback interface 2.2.2.2. This is for MPLS, for BGP to use. We have still not configured the loopback interface, but we know that even if you don't have an address on the loopback interface, any 32-bit ID can be given as a router ID. So this is not loopback interface, this is configuring router ID for BGP and MPLS. So this is not the one which I have highlighted. This is not in the list actually. What we are doing now is not in the list. Alright. Next is, okay, here we are configuring ISIS and loopback interface is configured as passive. It's good practice so that no hello packets will be sent, no advertisements will be sent, and ISIS is enabled on this 2 physical interface, and these 2 interfaces need to participate in ISIS, so we also join this to ISO family. So it's already INET family here on the top, and now it is also joining another family, ISO. Right, so I go copy this 5-6 lines, I put it here. Okay, I need to copy from this again. Done. Alright, so now comes the MPLS part. Here we are running MPLS on this physical interface, and on loopback in Cisco, when you try providing MPLS, it won't accept. But in Juniper, if you provide, it will accept, but it won't be useful. That's why we did not add loopback interface. LDP we do because it needs to provide reachability between loopback to loopback. Let me try doing for loopback interface. It won't throw error in Juniper, but in Cisco it won't accept. Here MPLS separately need to be enabled, like LDP also need to be enabled separately, not like Cisco MPLS, boom, LDP gets enabled. See, no error. Next. Okay, this is where we assign IP address to the loopback interface, set interface loopback 0, init 0, family init. Alright. Loopback to loopback reachability is very important for MPLS. So ISIS should be running on loopback. We already did it. Alright, next. Okay, so far we have finished up to ISIS, and I should be able to reach now between this PE2 to PE1, loopback to loopback. Let us test it. Here this is PE1, I'm going to say root, and then JUNIPER123 CLI show route protocol ISIS. Okay, I can see some routes. I'm also seeing 2.2.2.2. But unfortunately, I'm seeing only the path via the upper 10.15. I also need to see via this 10.16 equal cost path, so we need to troubleshoot now. Show ISIS adjacency. We have two adjacency. Let's go to P2 and check the same. Show ISIS adjacency. Only one adjacency. P5. What about P6? Something is missing. Show ISIS interfaces. Okay, I'm not seeing ISIS running on E2. It's not running on E2. Why? ISIS configuration. It's here. Oh, this is the problem. it didn't join the ISO family. I by mistake gave EM0, which is the customer facing interface. So let me go correct the word file. It's the problem here. This is, according to the topology, it is 2. Oh no. So let me save this and paste this one. No. Okay, so I did not remove that EM0 with ISO family. It is okay, it won't harm. Now let's see whether we see two neighbors. Show route protocol ISS. Okay, I can see equal cost path. Looks good. ISI story is over. Now moving on to the next level. We are configuring VRF. This is how we configure VRF. First is we define the name. Routing instance is the equivalent word for VRF. VRF is virtual routing and forwarding. You know that. We are creating a routing instance. We are creating a virtual router, a separate control plane for the customer. So the command is set routing instance, give a VRF name, and then say type VRF. Set routing instance and then give a name, cust -a, and then type instance type, and then what you have is VRF. The reason why I came here and I'm showing you here is next we'll be doing L3VPN. That's why. So right now we are not going to use MPLS command, we are saying VRF. Okay, so just the name is given, that's not enough. What is next? We need to assign the interface like this. EM0, this is the customer facing interface. So we say interface EM0.0, done. Next is we need to assign the route distinguisher and route target. Route distinguisher 102, route target 101. So route distinguisher 100:2 and route target with a community tag target 101. The command is not route target, it is VRF target, and then community tag name is target :100:1. This need to match with the other neighbors, so I'm copying 100:1. Yeah, done. So what is next is the main story is over. Okay, this is for labels to be added for VPN. So we are saying this so that labels can be allowed. Labels will be allowed for the customer routes, the service label. VRF table label. So advancing a single VPN label for all routes in the VRF. So when a customer advertises 10 prefixes, for each customer only one label. Advertising, not advancing, advertising a single VPN label for all routes in VRF. This is default in Cisco, but in Juniper you have to do this. For one customer, one label, not for every prefix one label. We call it as, in Cisco we call it as forwarding equivalence class. Forwarding equivalence FEC. Okay, the VRF story is over. And okay, this is the customer facing interface. The IP address is 22.00.22. So here we go. This is a familiar configuration line. Assigning IP address to the interface we know very well. So I'm going to copy paste again. Done. Alright, what is next? Very important, very important. BGP forming VPN. See, this is IBGP. The first two line is IBGP. And then with that IBGP we are forming VPN v4. That's third line. What is missing? Something is missing here. I can see remote AS is missing. Peer AS. Peer AS command is missing here. Okay. Let's put the peer AS is also 20. Alright, so though we say internal, we have to mention peer AS. I'll paste this for first two lines. Alright, next is I'm going to say this two line. Then this line which I just added. Comment. Okay, so now I'm expecting IBGP. Show BGP, not here. Show BGP summary. Still says active. Maybe I've not finished this on P1 IBGP. Show BGP summary. It's configured already, but is there anything missing? Show configuration protocol BGP. Remote AS is, peer AS is missing. Peer AS is missing. Here we have given peer is. There it is not there. Okay, now let us add that config set protocol BGP, the name group IBGP internal. Okay, that is already given. Peer AS is 20. Commit. Alright, let's now verify. Show BGP. Let's try pinging. Ping 2222 with the source 1111. We do have reachability, but I'm unable to see neighbor. So for one packet received, 2 packets sent out. Let's troubleshoot this. I'm going to capture packet. Okay, this is LDP messages. No BGP messages. I'll also capture the other link. I don't see any BGP packet going out. There is no BGP packet going out or any of this. Let's put TCP and check. All are LDP packets. Okay. So something is not correct. Protocol BGP group local address, neighbor address. Show config router protocol BGP. Oh no. This is the line that need to be removed now. First let's form IBGP, or we need to add this line on the other side. Okay, so So I'm going to add that one missing line so that the VPN conversation is what PE1 is ready to do. But on this side we did not enable VPN session, so let us add this, or we have to remove this from here. Anyhow we are going to do VPN, so I'm going to copy this and put it here. Okay, now I'm expecting the BGP packets to come. Okay. Show configure protocol BGP locally ASP is neighbor looks clean. What is the other missing piece? Simple IBGP. We have only INET VPN. We also need to enable INET, just INET, IPv4. So the command is set protocol BGP group IBGP and then family INET unicast. Commit. So this is now ready to send P1. Do I see anything coming from P1? Yeah, look at this. So that was the mistake. That was missing in the document. You know from where the document is created. So this is the line that is the missing piece. I add it here. Now the same line need to be added on the other side. PE2. Alright, so show BGP, here, show BGP summary. We see here the neighbor. No, not it. Okay, now yes, established. Alright, so we are ready. This has got two address family. One is L3VPN address family, another one is INET. Right, and the VRF is partially configured, so you can see this. But still we have not finished configuring the VRF over BGP. Have we done? I don't think we have done it. We have not done, so we will not have the route. Show route. We don't have route. Yeah, we don't have routes learned from the customer side too, because we are not running BGP, eBGP yet. That's our next step. So iBGP VPN is ready. This is the configuration for customer aware BGP to get the IP address from customer side. Set routing instance means for VRF we are enabling, we have this BGP, so it's not set protocol BGP, it's set routing instance name, and then protocol BGP group, any name, and then external, and then the peer is in 30, local is 20, peer is this address. So I think you're comfortable with this 4 lines, so I copy this and I paste it here. Oh, the buffer size. Next is local AS. And then the neighbor address is this is 30. It's good that we didn't copy. Okay, now the neighbor address we have to say neighbor address is 22.0.0.2 according to the diagram 22.0.0.2. Okay, next is what we need to join the INET family. And then this is to export the learned route into the VPN. Very important. And then put it into the VRF BGP. Alright, so that's it. I hope I have already given this MPLS command earlier. Yeah, set protocol. We need to enable MPLS family. Okay, this is the missing piece. We have to do this. Wait, that's all. Okay, now ready to verify. I'll close all this. Or let it go, We'll troubleshoot sometime if there is trouble. So show route protocol BGP. I can see the route coming via VPN and the route coming from eBGP. You see the AS path 10, AS path 30. So our route target, route distinguisher, everything works fine. That you can see here. This is the route target value. And we can see the labels. For the VPN. So it works fine. Now the ping will happen, but before that I would like to go to P1 and verify the same. Let's type show route. Simply first I am going to type show route. The global routing table we don't want now. This is what the cust A should learn these two networks. This is coming from IBGP. How do I know? When you learn from IBGP, you can see this. When you learn from IBGP, you won't. Then this is the next hop via EM0 we learned, and this is learned from IBGP 2.2.2.2 via these two, and we can see the other proof is it has got labels. Two layers of label. This is VPN label and this is the transport label. In Cisco you cannot see this clear. It shows you stack of label. This is going to be the same if you try pinging and when you check in Wireshark. Right, we can also see the same in this one, in MPLS table 9, see 29980. This is the label for the customer forwarding equivalence class. You see that here as well. It says it will send the packet via this two lines. This is the swapping label. So label to reach the next hop, that is going to be label number 16. So we got two. The top label is to move in the provider core network. This is to identify the VPN tunnel endpoint, the other end. The inside label is VPN label, service label. I think I said the opposite some time back. The top label is the transport label. It gets changed hop by hop. This label is the same till it reaches the PE2. Alright, what next is the verification by pinging. I'll go to customer let's check the route in the routing table first. Route password is JUNIPR123 CLI show route. Yes, we have learned this one via BGP. Here the administrative distance, which is called as local preference, it's same for eBGP and IBGP 170. and we see the AS path 20 is ISP, 30 is the remote site, and we can see the next hop address 11.00.11, which is PE1. Okay, now let us try pinging that address with the source of 172.16.0.1. As we ping, we are going to monitor using Wireshark. It may take any one of this path or both the path. Hit the ping. Okay, it is pinging, but I don't see any packet coming through this path. Unfortunately, I'm not seeing the packet. The ping is successful, the ping is going on, but the Wireshark surprisingly I'm not able to see in any of the path. But it goes via the path. It goes through the VPN, agreed, but it will be using the physical interface. So I'm trying to get it. I'll close and open. Capture EM1. In Cisco we will be able to see why this is. No, I'm not able to see. I don't know why PCAP, the packet capture, couldn't pick up that type of MPLS packets. I'm just trying to show you the stack, the VPN and the transport. See, the ping is going successfully. From site 1 we are picking site 2 address. So no packet lost, 149 packet sent and received successfully. VPN is working. Let's see trace 172.16.0.2 with the source 172.16.0.1. Okay. Because it is VPN, it is shown as just one jump, totally encapsulated. It's not showing the path that we used to see in Cisco. That is why PCAP couldn't capture. That's why. So in Juniper, for security reason, The TTL decrementation is not happening. That is the proof. You remember we learned that the TTL from layer 3 will be copied to MPLS layer and TTL decrementation will happen. That is Cisco. In Juniper, of course the TTL will be copied, but decrementation is not happening. That is the only reason why Wireshark cannot show us those packets, because the TTL decrementation is not happening. It just shows one hop. Are you convinced with the answer?
Absolutely.
Thank you. Thank you. So, how to make this decrement TTL? Include this on all the routers. Set forwarding option, no decrement TTL disable. Forwarding option, no decrement. Load balance, port mirroring, hashing. Let's try this. Delete protocol MPLS, no decrement TTL. Warning, segment not found. Sorry, statement not found. Do not decrement. Do not decrement the TTL within an LSP. We are cancelling that. It says that it's not found, but you are trying to cancel. So it simply says you are doing something useless. Delete. No propagate TTL. Disable TTL propagation from IP to MPLS. This is not to copy TTL. No, we don't want this propagation. We want only the decrementation. Disable TTL propagation from IP to MPLS and MPLS to IP. Okay, what is the use of that for us? I don't think it is useful for us. No. What if it is already disabled? PE1. Let me do it, though it says the command doesn't exist. and P1 and P2. Root JUNIPER 1 2 3. CLI and config. Okay, so though the statement is not seen, we said delete it, which is not really correct, but we did it hoping that it may support us. Let me trace root now. No, still the same. So